All right, welcome to Chapter 5. This is Section 5.1, Part 1, Trig Identities. What we're going to learn, or what we're going to try to figure out, is what is a trig identity and how can we solve problems with them. Okay, they're pretty challenging, so we're going to take this slow, make sure we go piece by piece. All right, so first we need to know what an identity is. An equation is an identity if the left side of the equation is equal to the right side of the equation for all values of the variable. So if the left and the right work for every variable, every number you plug in, it's an identity. So here is a possible example. We're going to figure out if this is an identity. So it doesn't matter what number we plug in here. Let's just plug in 2. Okay, this should work. This whole thing should work. So the right-hand side, 2 plus 3, okay, it should equal 5. So the left should also equal 5. So 2. So 2 squared minus 9 over 2 minus 3. So that's 4 minus 9 over 2 minus 3 is negative 1. So I get 4 minus 5 is negative 5 over negative 1. Does that equal 5? Okay, hopefully you see that negative 5 over negative 1 is 5. So this is an identity because no matter what numbers I plug in, the left side and the right side are equal to each other. Okay, so that's a definition of an identity. Okay, now what is a trig identity? The only difference is a trig identity is an identity that involves trig functions. Okay, so we have a bunch of trig identities here. We're going to separate these in pieces. Here's the first set. These are called the reciprocal and quotient identities. All right, so if you notice, there's two things at once, expression on each side, separated by an equal sign. That makes it an identity. These are all true. No matter what numbers you plug in here, you'll get these as true statements. All right. So what we do is we use these identities to come up with solutions to other answers that were not given. We're going to be given some information, and we need to figure out some new information based on all these identities. All right. So here's example number 1. It says, if cosecant of theta is 7/4, so I'm going to rewrite that here. And I'm going to get rid of the theta. You don't need that right now. If cosecant 7/4, we're going to find sine. Okay, so let's find a trig function or a trig identity that uses cosecant and sine. Okay, so notice here, what does it say? It says cosecant is equal to 1 over sine, or sine is equal to 1 over cosecant. Well, what are we trying to find? We're trying to find sine, so I'm going to use the one that says sine is equal to 1 over cosecant. Okay, so this first one right here. We're trying to find sine, and we know cosecant, so we're going to use this one right here. Okay, so all I did was rewrite it, and then we're going to fill in everything that we know. We don't know sine, but we do know cosecant. So sine is equal to 1 divided by 7/4. All right, well, how do we divide by fractions? We multiply by the reciprocal. So sine is equal to the top multiplied by the reciprocal of the bottom, which is 4/7. So what's 1 times 4/7? Hopefully you see that that's 4/7. Okay, and that should make sense. If cosecant is 7/4, isn't sine 4/7 because they're reciprocals of each other? Okay, that makes sense. But what we did was we used our identities to come up with solutions to unknown problems. Okay, so let's try this next one. All right, it says if cotangent, okay, so I'm going to write this over here. So we know cotangent is equal to 2 over 5√5, and we know sine is equal to √5 over 3. And what we were looking for is cosine. We don't know what cosine is equal to. Okay, so let's look at our reciprocal and quotient identities and see if we can figure out if there's one that has cosine, sine, and cotangent in it. Okay, so let's go back to that original document. So this one has sine, cosecant. That won't help us. Cosecant, sine, cosine, secant, secant, cosine. Tangent, cotangent, well it has cotangent, but that's it. Okay, now if we come over here, notice that this one right here, we know cotangent and we know sine, and we're going to try to find cosine. So that's the one we're going to use. Okay, so cotangent is equal to cosine over sine. Okay, so cotangent is equal to cosine over sine. So let's fill in everything that we know. We know cotangent is 2 over 5√5. I don't like the way that looks. Let me rewrite that. All right, let me rewrite that. So cotangent is 2 over 5 root 5, and that's equal to cosine, which we don't know, over sine, which we do know, which is root 5 over 3. All right, and all this basically is from now on is old school algebra. So I'm trying to get cosine, so how do I get rid of root 5 over 3? Well, I'm going to multiply both sides by root 5 over 3. Multiply both sides by root 5 over 3. Okay, so let's see what we get here. Root 5 over 3 divided by root 5 over 3 is gone. So I'm left with cosine on the right. And now let's simplify the left. So I can get rid of the root 5s because those cancel. Now I'm left with 2 on top. And I have 3 times 5 on the bottom, which is 2 over 15. Okay? Okay, so cosine is equal to 2 over 15. Can't reduce it. There's your answer. Okay, so we used our trig identities, okay, with the givens and knowns to find unknowns or not givens. Okay, so that's what we're going to do. All right, so that's the first set. We have a second set of identities that are very important. These are called the Pythagorean identities, and these are some of the most used identities in your list. These are called the Pythagoreans, and these deal with squareds. Okay, so we have sine squared plus cosine squared equals 1, and these should look familiar because we did do these in Algebra 2. We have tan squared plus 1 equals secant squared, and we have cotangent squared plus 1 equals cosecant squared. Okay, so we're going to start with these, and we're going to use these to help us find some new solutions. All right, so let's see what we have here. It says tangent, okay, so tangent is equal to -8. It's telling us that sine is greater than 0. And it wants us to find sine and cosine. So sine equals question mark, cosine equals question mark. All right. So what are we going to do to come up with, okay, something else? So all we basically know is we know that tangent is equal to -8. Okay. So if we go back to our Pythagorean identities, which one has tangent in it? Okay. So this is the only one. So basically we know tangent. We should be able to find secant. And then we'll use secant to come up with some other trig identities. Okay, so let's see here. So we're going to use the second one. So I'm going to rewrite this one over here. So tan squared plus 1 equals secant squared. And I know secant's not what we're looking for, but we'll be able to do something with secant and turn it into sine or cosine. All right, so tan squared. So -8 squared plus 1 is equal to secant squared. So 64 plus 1 is equal to secant squared. So 65 is equal to secant squared. Square root both sides, just like we ordinarily would. So secant is equal to plus or minus root 65. Okay, now this isn't what the answer we're looking for, but this will help us come up with sine and cosine. All right, so now we have secant, we should be able to find cosine sine. So let's go back here. There's no other Pythagorean identity that deals with secant other than the one we just used. Okay, so let's go back to our first table. And we're going to look for an identity that deals with secant that will be able to give us some other trig function. Okay, neither of these deal with secant, no secant, no secant, no secant, no secant. These are the only two that deal with secant. So this one right here says, these two say cosine is equal to 1 divided by secant. Okay, or you can use secant is equal to 1 divided by cosine. It does not matter which one you use. Let's just do the cosine one. It says cosine is equal to 1 divided by secant. Okay, so cosine is equal to 1 divided by secant. Okay, well, what is secant? Secant is plus or minus root 65. So cosine is equal to 1 divided by plus or minus root 65. Okay, everyone okay there? All right, so cosine, so how do I get rid of the root on the bottom? I'm going to multiply both sides by plus or minus root 65. So cosine is equal to 1 times plus or minus root 65 is plus or minus root 65. Root 65 times root 65 is just 65. Okay, so cosine's there. Now, we're going to have to figure out if the cosine is equal to positive or negative, but that is what cosine is equal to. We just have to figure out what sine it is. All right, so now we know tangent and we know cosine. We are now looking for sine. So let's find a trig function that deals with tangent, cosine, and sine all together. Okay? All right, so we're going to come over here. I'm going to get rid of this. Okay, so notice we have tangent is equal to sine divided by cosine. That's one we need to use. We know tangent, we know sine, we know tangent and cosine, we can find sine. All right, so that trig function said that tangent is equal to sine divided by cosine. So let's fill in what we know. We know tangent's -8. We know that sine, we don't know sine, and we know cosine is equal to √65 over 65. Now, let's figure out if this cosine is a positive or negative. We know from the beginning problem that tangent is a negative answer. Okay? So if tangent is equal to negative, and we know that tangent sine over cosine, what did they already tell us? They already told us that sine is bigger than 0, so they already told us that sine's a positive. So what does cosine need equal if it's positive of sine divided by cosine, if the tangent has to be negative? Well, the cosine has to be negative. Okay, so over here, I'm going to get rid of this plus or minus, and I'm going to put a negative because I know from what they give us that the cosine has to be negative. So I'm going to put this negative in front of it. Okay, so now we can use our simple algebra skills to figure out what sine is. All right, now how do I get rid of division by √65 over 65? I'm going to multiply by negative √65 over 65 to both sides. Okay, so that cancel. I'm left with sine is equal to. I'm going to put this over 1. Multiply straight across. What is negative √65 times -8? That's positive 8 √65. And on the bottom is 65 times 1, which is 65. So sine is 8 √65 over 65. Cosine is negative √65 over 65, and we have solved the problem that we're looking for. Okay, that's what they want us to solve. These are pretty challenging, but that's basically the gist of the beginning of the trig identity section. We're going to do example 4 in class tomorrow, so please make sure you leave that blank, and we'll do that one together. Have a good night, and I'll see you tomorrow.